Consider this example. Find the inverse Laplace transform of tan inverse 2 by s to the power 4. Now we want to solve this problem. Solution: L inverse tan inverse 2 by s square. We want to solve this problem. I recall the inverse Laplace transform of derivative L inverse fs. This equal to L minus 1 by t L inverse dds of fs. We know this formula. Now using this formula, this is minus 1 by t L inverse dds of tan inverse 2 by s square. We get this one. Now we know this formula, ddx of tan inverse x, this is 1 by 1 plus x square. So we assume this one whole is x. So L inverse dds of tan inverse x formula 1 by 1 plus s square. This, and this is using chain rule, 2 by s square we get. Now minus 1 by t, this will be, this is 2 4, this is s to the power 4, then 1 by 4 by s to the power 4, and 2 is outside, 1 by s square means 2 by s cube. If we solve directly, then we get this, because you know this formula, the dx of 1 by x to the power n minus n by x to the power n plus 1. We know this formula. By using this formula, 1 by s square, square means n, n by minus n by 2 plus 1, 3. Then this minus cancel, this 1 by t, L inverse, s to the power 4 LCM, s to the power 4 plus 4, next step s to the power 4 becomes a numerator, s to the power 4 by s to the power 4 plus 4, this is 2 to 4, 4 by s cube. We get this one. 1 by t, and this 4 taking outside, 4 by t, L inverse, this one cancel, s by, this is s to the power 4, s to the power 4 plus 4. We get this one. Now, we know this formula, a square plus b square. From lower class we know this formula. This is a plus b whole square minus twice ab. We know this formula. So s to the power 4 plus 4, we are using this formula. S to the power 4 means s square whole square, 4 means 2 square. This is a square plus b square, a plus b whole square minus twice ab, and this will be s square plus 2 whole square, 2 square, and s square we can write twice s whole square. Again I get a square minus b square formula, a square minus b square formula. This is the third formula in our life. This is a plus b into a minus b. We know this. So this will be a square minus b square. This is s square plus 2. This is s square plus 2 plus twice s square plus 2 minus twice s. Or we can write s square plus twice s plus 2, s square minus twice s plus 2. So this s to the power 4 plus 4, we can write this one. Now we want to write here 4 by t L inverse s by s square plus twice s plus 2 s square minus twice s plus 2. We can write in this way. This one I get. Now this is our last expression. So this can be written as 4 by t remains same, L inverse remains same. Now we express in difference of two terms. This is one factor, this is another factor. We want to write difference of two terms. 1 by s square minus twice s plus 2 minus 1 by s square plus twice s plus 2. We can write in this way. So this is, if we calculate this one, if we recalculating, taking LCM twice s plus 2 and s square plus twice s plus 2. If we recalculate, taking LCM, we get s square plus twice s plus 2 minus s square plus twice s minus 2. Then s square cancel, 2 cancel, we get 4s. We get 4s in numerator. That means we get 4s by s square minus twice s plus 2 s square plus twice s plus 2. We get 4s. Now, actually numerator is s. In our problem, numerator is, but if we recalculate this one, we get numerator is 4s. So we write 1 by 4. 1 by 4 we write down here. Next, this 4 cancel, 1 by t, L inverse. This is, we can write, we separate this, L inverse 1 by, this can be written as s square, this is s minus 1 whole square plus 1. In shortcutly, if we express in perfect square, we get this. And this is L inverse 1 by s plus 1 whole square plus 1. So we get this one. Again, first shifting property, L inverse f of s plus a. If we remove this a, then answer will be minus e to the power minus at L inverse fs. And if same formula we can write in this way also, s minus a e to the power at L inverse fs. This is our first shifting property. So if it is plus, then here minus. If it is minus, then here plus. That means if we remove a, then a becomes power of e. Now we want to remove this one. Then 1 by t L inverse 1 by t. If we remove 1, then e to the minus 1, we get 1t. L inverse 1 by s square plus 1. And this is remove 1, e to the power minus 1t, L inverse 1 by s square plus 1. Next we get, so 1 by t, e to the power t, this is direct formula, a by s square plus a square, this 1 square, this one sine 1t. And e to the power minus t, e to the power minus t, a by s square plus a square, this is sine 1t. Because we know this formula, L inverse a by s square plus a square equal to sine at. We know this formula. So from these two, sine t is common. We can write e to the power t minus e to the power minus t, and sine t is common, and by t we can write in this way also. And this is our final answer. So solution is long but not difficult. Just you have to using the technique, and without using this technique, this will be very long. If we using the partial fraction, then this solution will be very long. So we solve this problem without using partial fraction. So this is the complete solution. Now, dear student, the solution is clear. So today we stop here. Next class we shall start another video. Thanks.